So we have to prepare 250 ml of 1 by 50 m oxalic acid standard solution. This standard solution will be used to calculate or determine the molarity of an unknown solution. Okay. Now the molar mass of oxalic acid is given as 126 gram per mole, and the formula of oxalic acid is COOH COOH.2H2O. When we calculate its molar mass, that comes out to be 126 gram per mole. To prepare this solution, we require two things. First of all, we require distilled water, and second thing, we require oxalic acid. How much distilled water is needed to prepare this solution? As we have written, we have to prepare 250 ml of this solution. So we need 250 ml of distilled water to prepare this solution. Now the question is how much or what mass of oxalic acid is required. So we have a formula to calculate mass of oxalic acid. Mass of oxalic acid required is molarity of the oxalic acid solution multiplied by molar mass of oxalic acid multiplied by volume of solution in liter. Now as our question says, molarity of the oxalic acid solution is 1 by 50 mole per liter. So we have applied this 1 by 50 molarity here. Now the molar mass of oxalic acid is 126 gram per mole. So we have written it 126, and the volume of solution is 250 ml. So when we divide this 250 by 1000, then the volume is converted to liter. Finally, the mass of oxalic acid required is equal to 1 by 50 into 126 multiplied by 250 upon 1000. That comes out to be 0.63 gram. Now to prepare this solution, we will dissolve 0.63 gram of oxalic acid in exactly 250 ml of distilled water. To prepare 1 by 50 m and 250 ml of oxalic acid solution, we require certain things. First of all, we require exactly 250 ml of distilled water. We require an empty beaker. We require a weighing machine, electronic weighing machine. This is oxalic acid that we have to dissolve. We will wait, and we require a small beaker. Now the first step is we transfer this 250 ml of distilled water in this beaker. Okay. Now we have 250 ml of distilled water in this beaker. Now we have to weigh oxalic acid. How much oxalic acid is required? 0.63 gram oxalic acid is required to prepare this solution. So now what we will do? We will put this beaker here, and once we put this beaker here, we can see that this machine is reading the weight of this beaker. So we will apply tare. Once we apply tare, this weighing machine is reset to 0. Now this weighing machine will weigh only the weight of oxalic acid. Now we have to weigh 0.63 gram oxalic acid. You can see it is 0.38 gram. We require little more of oxalic acid. Now the weight is 0.56 gram. Now it is 0.60 gram. Okay. Now the weight is 0.64 gram. Okay. Finally, we will transfer this oxalic acid into this 250 ml of water. Okay. And we will carefully stir this solution so that we have got 250 ml of 1 by 50 m oxalic acid solution. This solution is ready now. Okay. So the aim of today's experiment is to determine the molarity and strength of given NaOH solution by titrating it against a standard 1 by 50 m oxalic acid solution. The molarity of oxalic acid solution is known, which is 1 by 50 mole per liter. But the molarity of NaOH solution is unknown. So the target is to determine the molarity and strength of this unknown NaOH solution. To perform this titration, we have a set of formulas. First of all, the formula that we use for titration is M1V1 is equal to M2V2. Now this portion belongs to NaOH and this portion belongs to oxalic acid. NaOH is a base which gives 1 hydroxyl ion per molecule, and oxalic acid is an acid which provides 2 H ions per molecules. So we apply a factor of 1 here and a factor of 2 here. So the formula becomes M1 V1 is equal to 2 M2 V2. The readings that we are going to take through our burette. Now 2 is, we know, it is the factor. 1 by 50 is the molarity of oxalic acid solution, which is given in our question, and 20 ml V2 will be 20 ml, that will be the volume of oxalic acid which we will use for titration. Now this M1 comes out to be 4 by 5 into burette reading. Once we fill this burette reading in this formula, we will get molarity of NaOH solution. And after determining the molarity of NaOH solution, we can calculate the strength of given NaOH solution using this formula. So what is the formula of strength to calculate the strength of NaOH solution? Strength of NaOH solution is equal to molarity of NaOH solution multiplied by molar mass of NaOH solution, and we know molar mass of NaOH solution is 40 gram per mole. Now only thing we have to do is put the value of molarity of NaOH solution in this formula, and we will get the strength of NaOH solution in gram per liter. Now we have an observation table here. In this observation table, we will take a minimum of 3 readings. Okay, because our burette starts from 0, our initial burette reading will be 0, and whatever readings we will obtain from our burette, we will fill in this observation table. And 2 similar burette readings are termed as concordant burette readings, and these concordant burette readings can be used in this formula. Okay, now we will perform it. Now let us see whatever chemicals and apparatus are required for the titration process. First of all, we require an unknown solution of NaOH. Of course, we know that this is NaOH solution. The question is, what is the molarity and strength of this NaOH solution? Second solution that we require is a standard solution of oxalic acid. This is 250 ml of 1 by 50 m oxalic acid solution. This is called as our known solution. Now we require a measuring cylinder. These days we do not use pipettes because pipettes are unhygienic, so we are using measuring cylinders. After that we require a conical flask. Okay, now the main thing is this burette. Okay, now let me introduce. This is a funnel, this is a burette, this is a burette stand, of course, and these all things are required for our successful titration process. Okay, let us start this process. First of all, you keep a small beaker right here. Now let us start our titration. We will fill this burette with this NaOH solution, but make sure before you fill this burette with NaOH solution, you remember that you stir it well. Now with the help of this funnel, I am going to fill this NaOH solution into this burette up to 0 level mark. Okay, we are running this NaOH solution down into the burette. Once it is filled up to 0 level mark, we will observe that it has got 50 ml of NaOH solution into it. Now I can see that the level is above 0 level, so I will eliminate some of the NaOH from this burette. Now we will zoom it and see that this burette is filled up to 0 level mark. Zoom it. Is it visible? Okay. Now this burette is ready for titration. Let us get rid of this funnel. Okay. Now we need to measure 20 ml of this oxalic acid solution with the help of this measuring cylinder. We have already added phenolphthalein indicator in this oxalic acid solution. Phenolphthalein does not give any color with oxalic acid, but with NaOH it will give pink color. That will be our end point. So let us start. Okay, now I am taking 20 ml of this oxalic acid solution. Now we will transfer this oxalic acid solution in this conical flask. That's fine. Now place it here. We will start running NaOH solution into this oxalic acid solution. Now please zoom it. You can see that there is no color being developed in this conical flask, but as soon as this titration will end, we will achieve our end point. We will see light pink color at the bottom of this conical flask. Now if you can please zoom it for me. We are getting light color here. Okay. Keep patience. Keep running this NaOH solution into oxalic acid. You will observe that this pink color is getting to settled. Okay. Still we haven't got our end point. We need a few more drops of oxalic acid. Okay. Now pink color is appearing. Okay. Now you can see that we have got very light pink color. So we have reached our end point, and now we can record our first reading. Our first reading seems to be at 13.8 ml. Okay. Now it is well visible. Huh? Okay. So we have successfully taken our first reading, and now it is time to fill our first reading in our observation table. We started from 0 and first burette reading was 13.8 ml. So when we minus 0 from 13.8, net volume of NaOH used is 13.8 ml. Now for second reading, our initial burette reading will be 13.8. Okay. Now let us proceed to take second reading. Now we are on the way towards our second burette reading. First of all, we will repeat this procedure. We will take 20 ml of oxalic acid solution with the help of this measuring cylinder. Okay. Now again we have this 20 ml of oxalic acid solution in this measuring cylinder. Now what we need to do? We need to transfer this oxalic acid into this conical flask. We have done it. Now our reading will start from 13.8. Our initial burette reading is 13.8. Now you can see that pink color is settling down. We have some stable sort of pink color. So now make it very slow. Okay. We have got a very light pink color here, but it has discharged. So I will add a few more drops of oxalic acid into this solution. Okay. Now this is our end point. We have reached our end point. This is light pink color. Okay. Now we have obtained our reading at 27.6 ml. Will you please zoom it? Is it visible? Okay, done. Now our second burette reading is 27.6 ml. So when we minus 13.8 from 27.6, again we get 13.8 ml. Because we have obtained two similar burette readings, which are our concordant burette readings, we need not perform third reading. If you want to, you can. If you don't want to, then it's okay. So let us put this reading here, 13.8 ml. Now it is time to calculate the molarity of given NaOH solution. Okay, let us place it here. Now our formula for molarity was 4 by 5 into burette reading. I will apply it here, 4 by 5 into 1 upon 13.8. Now it comes out to be 4 upon 69 moles per liter. You can calculate it further. Now to calculate the strength of given NaOH solution, we will put this molarity M1 here, 4 upon 69, and this comes out to be 2.3 gram per liter. That means the molarity of our NaOH solution was 4/69 mole per liter, and the strength of this NaOH solution was 2.3 gram per liter. I hope you understood this experiment. Thank you very much.